This related rates problem is regarding price and demand. One big question that we usually answer in related rate problem is how does the change of one variable affect the change of the other variable? Again, in a related rate problem, we are trying to answer one big question. How does the change of one variable affect the change of the other variable? Let's read the problem first. The weekly demand of a product and its selling price can be described using the following equation, where P represents the selling price measured in dollars and X represents the unit demanded in thousands. So for example, when X is equals to 3, that means 3,000 units. All right. The first question is, what is the rate of change of the demanded unit when the selling price is $50 and the demanded unit is 2,000? The selling price is increasing at $9 per week. So the note is the rate of change. Sometimes they use the words how fast means finding derivative. So we have an equation down below that is 4x squared plus P equals to 256, and X is the demand in thousand and P is the price in dollar. So the way I interpret this type of application problem is they write a couple sentences to describe the entire case scenario, right? And then they give you an equation and then they give you the meaning of each variable. So here is how I interpret all these types of application problem. So whatever you are describing can be described using one equation. So that means you have something going on right now and then they introduce a few variables and I can use one equation to describe the entire situation. So in this problem, they are describing a business and then they give me one equation to describe the entire situation. All right, so whatever is going on can be described using one equation. And then in the first and the second question, they ask the rate of change, they ask how fast. So every time I see rate of change or how fast, that means derivative. So how do we take derivative? We have two different variables. So this, they are trying to say this is with respect to time. Do you see that this is per week? So the time t is week. So this one, they set the rate of change of the demanded unit when the selling price is $50 and the demanded unit is 2,000, and the selling price is increasing at $9 per week, right over here at $9 per week. So the time variable is week. Remember, when it comes to related rate, usually there is a time variable. In this problem, the time variable is per week. So that means we are taking the derivative with respect to time t. Okay, the time unit is week, so we are using implicit differentiation to take the derivative of the equation with respect to week. So what we are going to do next is we are going to differentiate both sides of the equation with respect to t. All right, so let's use implicit differentiation. So this is with respect to time t. So the derivative of 4x squared is what? So we are going to bring the 2 down, so that is 8. And then the derivative of 4x squared is 8x. So since this is with respect to t, and then we have to add a dx dt. X is the independent variable, and then t is the time. We have to add a dx dt. And then the derivative of p is equals to 1. And since this is with respect to t, then we have to add a dp dt. And then the derivative of the constant is equals to 0. And then this is implicit differentiation. So implicit differentiation and then what's next? So the next job is you have to pick up the givens from the problem. So they set the rate of change of the demanded unit. So that means they are asking for dx dt. So dx dt, we don't know. When the selling price is $50, so P is equals to 50, and then the demanded unit is 2,000. Should I let X equals to 2,000? The answer is no. So you should just let X equals to 2, because the X is already in thousand. Do you see this? The demand is in thousand. So if you say X is equals to 2, that means 2,000. You don't have to add the 3 zeros. So X equals to 2. The 2 is already in thousand. And then what else? The selling price is increasing. So do you see this? Read the first problem, the second sentence, the second line. The selling price is increasing. The word increasing is very important. That changes the whole game. It's increasing at $9 per week. So this is how I do it, the price. So I'm going to write dPdt. So dPdt is equals to past step 9. I'm going to mention the past step as well because this is increasing. $9 per week. So dollars per week. And then they are asking for dxdt. So all you have to do is you plug this into the equation and then just solve for dxdt. So we have 8 and then x is equals to 2. dxdt don't know. And then plus 1 times dPdt 9 and then equals to 0. Now let's mention a what if. What if in the second line they mentioned that the selling price is decreasing at $9 per week? What if they say decreasing? If they say decreasing or going down at $9 per week, then the dPdt is negative 9. Again, for the dPdt, the derivative, dxdt, dPdt, I don't really care. If they say increasing, then the value is positive. If they say decreasing, then the value is negative. Rate of change, right? Means the slope. Slope can be going up, positive. Slope can be going down, negative. All right, let's solve for dxdt. So we have a 16, right? So this is a 16, and then this is a 9. So that means dxdt. So first we subtract 9 on both sides, and then we divide both sides by 16. So this one is equals to negative 0.5625, and then the unit is in 1,000 units per week. So 1,000 units per week. And then since this is in 1,000, then how many units exactly? Negative 0.5625,000. That sounds weird. Can you put this back to not 1,000? So to get rid of the 1,000, so negative 0.5625, all you have to do is multiply 1,000. What does that mean? That means you have to take the decimal, you move the decimal point 3 steps to the right. So 1, 2, 3. So that is equals to negative 526.5 units per week. So since this is negative, what does that mean? That means the demand is going down. So the demand is going down, is decreasing, is dropping. So the rate of change can be going up or going down. So this one, the demand is negative. That means the demand is going down. What if the demand is past the 562? Then that means the demand is going up. So that answers the first question. So this one, let's box this. So that answers the first question. All right. So let's move on to number 2. So for number 2, they are asking how fast is the selling price changing with respect to time? How fast? What does how fast mean? How fast means rate of change. When I see the word rate of change, how fast, the first thing that comes into my mind is take the derivative with respect to time. And then they give you some givens, right? So let's do the derivative one more time. So let me change to another color. So we have the given equation, and then we take the derivative on both sides with respect to time using implicit differentiation. So you bring the 2 down. So 4 times 2 is 8. And then x with respect to time, then we have a dx dt. And then the derivative of p is equals to 1 with respect to time, then we have a dp dt. The derivative of 256 is equals to 0. And then they said the demanded unit is 500. So x equals to 1, that means 1,000, right? So how about 500? 500 is half of 1,000, so half of 1 is 0.5. So in this problem, x is equals to 0.5. And then the rate of change of the demanded unit is decreasing. And then dx dt, this is the demand, is decreasing at 2,000 units per week. So that will be a negative 2. Because the negative means decreasing, you have to mention the negative. So that's why for the previous problem, I mentioned a positive 9. So that's why I put the positive 9. So even though the positive side is not necessary, I do it anyway. And then what they're asking the rate of change of the price, right? So that will be dp dt, don't know. All right, plug in everything. So we have 8 times x equals to 0.5, dx dt is -2, and then plus 1 times dp dt, which is what we don't know, that is equals to 0. So we have to take the 8 times 0.5, that is equals to 4, right? And then 4 times -2, that is -8. So we have -8 plus 1 times dp dt equals to 0. So first of all, we add 8 on both sides. And then we divide both sides by 1, right? -8. So we add -8. We add that on both sides. So dp dt is equals to 8 divided by 1. That is equals to 8. And then what is the unit? The unit is $8 per week. What does that mean? So since this 8 is positive, that means the price is increasing at $8 per week. What if dp dt is negative? That means the price is decreasing at $8 per week. What if dp dt is 0? So positive means increasing, negative means decreasing. What about 0? 0 means the price is not changing at all, right? So again, positive means increasing, negative means decreasing, 0 means no change at all. And then let's take a look at number 3 and number 4. So number 3, in pink, how many units will be demanded if the selling price is $20 per unit? So this one, they didn't ask for any rate of change, so no rate of change, no how fast or similar words. They only give you the price, and then they ask for the unit. So let's mention the equation again. So the equation is 4x squared plus p equals to 256. X is demand in thousand and p is the price, and then they gave you the price is $20 per unit. So all you have to do is you solve for x. So we don't know x. So this is 4x squared plus 20 equals to 256. So we have 4x squared equals to 256 minus 20. So that is equals to yes. So 256. So we have 236. And then we take 236 divided by 4. So x squared is equals to 236 divided by 4. So that is equals to 59, right? So let me make sure. And then we take that divided by 4. That is equals to 59 exactly, because I want to make sure that we don't need to round. Is this the right answer? Is the demand equals to 59? The answer is no, because this is a demand square, so we have to take the square root on both sides. So square of root of 59, so that is around 7.681. If you ask me, hey, back in algebra, for x squared equals to a quantity, when you take square root on both sides, we have to use the plus or minus. So how come there is no plus or minus? Because the number of units cannot be negative. So in this application problem, it is not necessary to mention the minus. So this one is in units. Do you want to give 0.6 units to your customer? So the answer is no, right? So therefore, in this type of situation, we usually round up to 8 units. What if that is 7.1 or 7.2 units? We still want to round this up, because 7.1, right? So let's say I own you 7.1 units. So I have to give you 7 units first and then give you 0.1 unit. Do you want 0.1 unit? Do you want 10% of a product? No, right? So instead of giving you 7 units, so 7 units, that means I haven't met your demand is not met, right? If I give you 7 units, the demand is not met. If I give you 7.1 units, you are not happy with the 1.1 unit. So therefore, I have to give you 8 units to make you happy. So that's why we always round up. Okay, so last one. Selling price don't know. The demanded unit is 1,000. So the demanded unit is equals to 1,000. So since the x is already in 1,000, all you have to do is you let x equals to 1, right? So we let x equals to 1. So let's do it. So when x is equals to 1, and then p don't know. That is what we are trying to find out, right? The price we don't know. 4 times x squared plus p equals to 256. So we have 256 minus 4, that is equals to 252. So that's it. So this is $252 per unit. So if you are thinking that how come sometimes the numbers, they don't sound realistic, don't worry about the realistic and unrealistic. I am giving you a problem to explain all types of situations. So don't worry about the numbers. All you have to do is you have to be able to read the problem and be able to drop down the givens. So for example, when you read the rate of change or the how fast, you have to be able to write down that is dx dt or dp dt. And then the increasing, decreasing stuff, you have to know whether that is a positive or negative. All right, so that is the end of this video. If you think my instruction is helpful and clear, give me a like, share the video for me, click the subscribe button if you are new to the channel. I appreciate your help and support. I will see you all in the next one. Signing out.